Today I'm going to teach you how to find out an cardiac axis. So this is in cardiac axis determination. Now what is cardiac axis? It is nothing but cardiac dipole. What is cardiac dipole? That is a mean QRS complex. That is a electrical activity which is flowing in the heart. The average thing. Okay. So there are two major methods. One is accurate method and the other one is approximate method. The accurate method is by using an Itovian triangle and approximate method is by using hexaaxial method. Okay, so first of all we'll see the Itovian triangle method. Okay, so in this method, first of all you have to draw an equilateral triangle. So I have drawn an equilateral triangle here. Okay, so this is an equilateral triangle of 8 centimeter I have drawn. This is the midpoint of equilateral triangle. You have to take in perpendicular from each side and you have to find out the central point. Okay, then all of you know this leads. This is lead 1, lead 2, lead 3, and now how to plot the axis. First of all of you know that ECG, one small box is equal to 1 mm. Okay, so first of all you have to find out the amplitude of QRS complex. Now how to find out the amplitude of QRS complex? Amplitude of QRS complex is equal to amplitude of R wave minus amplitude of Q wave or S wave, whichever is larger. Okay, so whichever wave is larger you have to deduct it from the amplitude of R wave. Now if you see ECG, there are small boxes. Now one small box is equal to 1 mm. So if you find out, this is an baseline. If you find out the number of boxes in R wave, so from here to here, number of boxes, there are 10. So amplitude of R wave is 10. Now here the big wave is, if you see the negative wave, this is which wave? S wave. So Q R S. So it is occupying two small boxes, so 2 mm. As it is a negative wave, negative. So plus 10 minus 2 is equal to plus 8. Okay, so this is how we are finding out the amplitude of QRS complex in lead 1. Okay, same way you have to find out the amplitude of QRS complex in lead 2 and in lead 3. So how to find out? You have to deduct the number of small boxes of R wave minus number of small boxes of Q or S wave. Okay, that is 1 mm. Small box is 1 mm. So here we got in lead 1 it is plus 8. Now we have to plot it on the Itovian triangle. So as we know, there are charges across the lead. This is minus charge, this is plus sign. This is minus, this is plus. Same way in lead 3, this end is minus, this end is plus. So here the amplitude of lead 1 is 8 mm. So towards positive lead you have to draw this 8 mm and mark it like this toward the positive end. In lead 2 it is 10. The amplitude of QRS complex is 10. So towards positive lead, positive side of the lead 2, we have to mark up to 10 mm. Okay. Same way for lead 3, the amplitude is plus 2. So towards the positive side you will mark 2 mm. Now you have to draw a perpendicular line from your markings. Okay, so this is a point where they meet. So from center of equilateral triangle to that point you have to draw an arrow. So this is mean QRS complex or a vector of a heart. So this you can find out by accurately measuring this length. You will get amplitude of QRS complex axis. So if you find out by amplitude, it is around 10 mm. And if you find out the angle, you can find out the angle, you can extend this and accurately you can get the angle. So angle is around here somewhere, that is 60. Okay, so this is how you can find out the cardiac dipole by using Ethiopian triangle method. Okay, so first step is, first you draw the equilateral triangle, then you find out the center of the equilateral triangle, then you find out the amplitude of QRS complex in lead 1, 2 and 3. How to find out the amplitude? Amplitude of R wave minus amplitude of S wave or Q wave, whichever is larger. So this is how you get your amplitude of QRS complex. Then you have to plot it on the leads like this. You have to go towards the positive side, towards the positive side, towards the positive side. Then you have to join this, you have to draw the perpendicular from that points, and you have to find out the joining point. Then you will draw from center of the triangle to that joining point an arrow. Then you can find out the amplitude of cardiac dipole by measuring this length of arrow, and you can find out the angle by measuring the angle like this. So you will get an cardiac accurate value of cardiac axis. Okay, so this is method by Ethiopian triangle. Now we'll see by method, that is approximate method called as hexaxial method. There is one more method, that is quadrant method.